Assalamu alaikum, my dear students. I hope all of you are fine and having good health. So in our today's video, we are going to discuss about the mass spectrometry. So the mass spectrometry, this topic is new to you. Basically, mass spectrometry, it is an analytical technique. Analytical technique means to analyze. Analyze mean to have a check. Now, what thing we are going to check and for what purpose this technique is going to be used? Basically, in this technique, a chemical substance are identified. Then how it can be identified? Basically, first of all, they are changes into their gaseous ions in the presence of electric and magnetic fields according to their mass to charge ratio, where the mass to charge ratio is mass to charge ratio. So basically, mass spectrometry, it is a technique in which we analyze the substance and we just measure the exact masses of the isotopes. So here the main work is to measure exact masses of isotopes. So for this purpose, we use the different mass spectrometer. So we use the different mass spectrometer. Here we have two types of mass spectrometer. The first one is known as the Aston's mass spectrometer, and the second one we have it is known as Dempster's mass spectrometer. So Aston's and Dempster mass spectrometer, basically Aston's mass spectrometer or the spectrograph, it is used and it works on the basis of the atomic masses. It works on the basis of atomic mass. So this is a simple picture of the Aston's mass spectrometer. And now we have the modern mass spectrometer or the spectrograph. Its name is Dempster and it has been designed for the identification of the elements that are present in the solid state. So this is the picture of the Dempster's mass spectrometer. Okay, how it works? What is the internal structure for the working of the mass spectrometer? So we have first of all the sample enters over there and it is heated by the heat vaporizer. So here the sample is converted into the vapors and then an electron beam source is applied over there, and here the main purpose is the ionization, and the sample is converted into the gaseous positively ions. Now these ions are passes through the electric field. So the electric field is applied. Basically the electric field that we apply over there is voltage of 500 to 2000 volts applied over there. So the ions are deflected towards the negative plate. They are deflected towards the negative plate. After that, we applied the magnetic field. So here the magnetic field is denoted by the capital H, and the magnetic field that we apply over there, it allow the ions to move in the circular path. And when they are moving in the circular path, they have the specific radius, and the radius is denoted by the R. After that, they fall according to their mass to charge ratio over the detector. where we have the electrometer. So the electrometer basically it measures the current. When they fall on the specific electrometer, as they have their mass to charge ratios, so they just produce the minute electric field, and that electric current is measured and it is then amplified, and on the strength of the electric current that they produce, we just have their uh, mass of the isotopes. We have the mass of isotopes. So this is a simple working of the mass spectrometer in which we have different terms. Next, we have the process in the mass spectrometer. So that was the just internal section. Now we have the main process. First one part is the inlet where we have just the introduction, or we just induce the sample. After we have the ion source that makes it into the gas phase. And after we have the mass analyzer, and at the end we have the detector. So I'm going to write the complete process over there. First one, we have the inlet, then the mass is vaporized. After that, we have the ionization, and after the ionization, we applied the electric field, and after the electric field, we applied the magnetic field, and after the magnetic field, we have the electrometer to measure the current, and the last one, we have the detector, and then a graph is plotted. So this is the simple process in mass spectrometer, that how it works. This is the spectrograph. It works on the basis of the modern work in which when the collector collects the ions, then the detector just amplified the results, and after the amplification of the result we just gain a graph that is known as the spectrograph. And how the spectrograph work, here we have the relative abundance along y-axis, and we have the mass to charge ratio along x-axis. So here we have the simple, for example, there was a three isotopes. The first one 1.67, second one is having mass to charge ratio 0.50, and third one is 47.6. So how the mass spectrometer works, basically here we have to find the mass of the different isotopes. So the basic work is to find the mass of isotopes. To find the mass of isotopes, we use the mass spectrometer in which the sample has been placed, and at the end we record the result in the form of this spectrograph. So from here we can have the average masses of the isotopes. So this is all about today's lecture, and in the next section we will discuss about the average atomic mass, that what does mean by this and how we can measure this. For that time, guys, have a good day and Allah Hafiz.